friends. Today we shall solve numericals on electric charge and electric fields, and follow NCERT textbook exercise problems. First one is 1.1. I have written here only symbolically, and for numerical problems you follow NCERT textbook. What is, first problem 1.1, what is the force between two small spheres having charges 2 into 10 raised to minus 7 coulomb and 3 into 10 raised to minus 7 coulomb, separated by a distance of 30 centimeter in air or vacuum? Therefore, here given two charges, Q1 equal to 2 into 10 to the power minus 7 coulomb and Q2 equal to 3 into 10 to the power minus 7 coulomb. They are separated by distance, that is R is equal to 30 centimeter. Convert it in meter, that is equal to 0.3 meter. To convert centimeter into meter, divide it by 100 or multiply with 10 raised to minus 2. Then what is the force between these two charges? Solution. According to Coulomb's law, the force of attraction or repulsion between 2 point charges is directly proportional to magnitude of charges and inversely as the square of the distance between them. Thus, Coulomb's force F is equal to 1 upon 4 pi epsilon naught into Q1 Q2 upon R square, or it can also be written as K into Q1 Q2 upon R square, where K is Coulomb's constant, and for air medium K equal to 1 upon 4 pi epsilon naught, and its value is 9 into 10 raised to 9 Newton meter square per Coulomb square. Therefore, it is a constant. Therefore, for air medium K equal to 9 into 10 raised to 9 Newton meter square per Coulomb square. Now, substituting these values, we get K equal to 9 into 10 to the power 9 into Q1 is 2 into 10 to the power minus 7 into Q2 is 3 into 10 to the power minus 7 upon R square, but R equal to 0.3 square, that is equal to 9 2s are 18, 18 3s are 54 into 10 raised to minus 14 plus 9, that is 10 to the power minus 5, divided by 0.3 square is 0.09, and 0.09 can be written as 9 into 10 raised to minus 2, or you can write 10 raised to plus 2 in the numerator, or in the denominator write 9 into 10 raised to minus 2, or in the numerator it is 10 raised to plus 2. Now, 9 ones are 9, 6s are 54, that is 6 into 10 to the power minus 5 plus 2, that is minus 3 Newton. Therefore, the force between two charges is equal to 6 into 10 to the power minus 19 Newton. And if we consider the force on one due to the second, it is also true. And it is equal in magnitude and opposite in direction to the force on second charge due to the first charge. For point charges, force of attraction or repulsion, they are mutual forces. Hence, force between two charges is 6 into 10 raised to minus 3 Newton. Note down. Pause the video and you can note down these values. Now, next problem. The force on a small sphere having charge 0.4 microcoulomb due to other small charge minus 0.8 into 0.8 microcoulomb is 0.2 Newton. Then what is the distance between two spheres, charged spheres, and also find the force on second charge due to first charge. Here given force on first charge due to second is equal to 0.2 Newton and Q1 is equal to 0.4 microcoulomb and 1 micro equal to 10 to the power minus 6. Therefore, this Q1 equal to 0.4 micro is nothing but 10 raised to minus 6 coulomb and Q2 is equal to minus 0.8 microcoulomb, that is equal to minus 0.8 into 10 to the power minus 6 coulomb. Then what is R? Separation between the charges, and also find force on second due to first. First we calculate the separation between two charges. Number 1. Here also Q1, Q2, F are given. Therefore, R can be calculated. They are related by the relation F equal to K into Q1, Q2 upon R square. Here we write F12 force on first charge due to second charge is equal to K, where K equal to 1 upon 4 pi epsilon into Q1, Q2 upon R square. These quantities are given. This implies R square equal to K Q1 into Q2 upon F1 2. For air or vacuum, K equal to 9 into 10 to the power 9 into Q1 is 0.4 into 10 to the power minus 6 and Q2 equal to, here negative sign is not taken, only the magnitude of charges, 0.8 into 10 to the power minus 6 divided by F12, that is 0.2, and that is equal to 9 into 0.4 into 0.8 is equal to 2.8 8 into 10 raised to minus 12 into 10 raised to plus 9, that is 10 raised to minus 3, divided by 0.2, and it is found to equal 14.4 into 10 to the power minus 3, r square equal to, but r equal to, now this 14.4 into 10 raised to minus 3 can also be written as 144, that is multiply with 10 and divide it by 10 into 10 raised to minus 4. This is equivalent to 144 into 10 raised to minus 4. Now you can take square root on both sides. Square root of r square is r, and square root of 144 is 12, and square root of 10 raised to minus 4 is 10 raised to minus 2 meter, or it can also be written as r equal to 0.12 meter. This is the separation between two charged spheres. Then what is the force on second charge due to first charge? Since these are point charges, and according to Coulomb's law, the force of attraction or repulsion between 2 point charges are mutual. Yeah? That means force on first charge due to second is equal to force on second charge due to first charge. Therefore, what is the force on second charge due to first? Since Coulomb's force is mutual in nature. Therefore, force on first charge due to second is equal to force on second charge due to first, and that is equal to 0.2 Newton. Note down this. Now next, third problem. Next, 1.3. Check that the ratio Ke square upon Gme mp is dimensionless, and also find the numerical value of this ratio. The given ratio is Ke square upon G me into mp. Here K is Coulomb's constant, E is electronic charge, G is universal gravitational constant, me is mass of electron, and mp is mass of proton. To show the ratio is a dimensionless, first write the units of all these constants. Writing SI units. Writing SI units of these quantities. K is Coulomb's constant and its SI unit is Newton meter square per coulomb square. This is the SI unit of Coulomb's constant K. And unit of charge is coulomb, and E square is coulomb square. Coulomb square divided by the SI unit of universal gravitational constant. In previous first PUC you have studied, and the unit of universal gravitational constant is Newton meter square per kg square into mass of electron, it is in kg, and mass of proton, it is also in kg. Kg into kg, kg square. Kg square. Now here Newton get cancelled, meter square get cancelled. Then C raised to minus 2 into C raised to plus 2 is equal to C raised to minus 2 plus 2 is equal to C raised to 0, and C raised to 0 equal to 1. And in the denominator, kg raised to minus 2 into kg raised to plus 2, that means kg raised to minus 2 plus 2, that is kg raised to 0 is equal to 1. Therefore, the dimensions of this ratio is 0 in mass. Mass has no dimension, kg, that is equal to 1, and 0 in length and 0 in time. The dimensions of a physical quantity is expressed in terms of fundamental physical quantities, that is in terms of mass, length and time. Therefore, dimensions of this ratio are 0 in mass, 0 in length and 0 in time. Therefore, the given ratio is dimensionless quantity. Therefore, Ke square upon G me mp is dimensionless. It is dimensionless quantity. This is first. And in second, and find the numerical value of this ratio. All these are constants and they have the constant values. Substituting the constant values of K, E, G, Me and Mp, we get the numerical value of this ratio. Now second, numerical value. Of Ke square upon G Me Mp. That is the value of K in if a proton and an electron is placed in air medium or vacuum, then the constant K equal to 1 upon 4 pi epsilon naught, and its value is 9 into 10 to the power 9 Newton meter square per coulomb square. And E is electronic charge or fundamental charge. Charge on an electron is 1.6 into 10 to the power minus 19 coulomb. Therefore, 1 into 1.6 into 10 to the power minus 19 coulomb. This is E, its square, E square upon G is universal gravitational constant and its value is also constant. You have studied in first year. that is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Then ME, that is mass of electron. Mass of electron is constant and it is equal to 9.1 into 10 to the power minus 31 kg. And that the mass of proton is also constant and it is equal to 1.66 into 10 to the power minus 27 kg. Mass of proton is 1.66 into 10 to the power minus 27 kg. Solving, we get this is equal to 2.3 into 10 to the power 39. It has no unit because the ratio is, it contains similar quantities, and it signifies that the numerical value of this ratio is 2.3 into 10 raised to 39. It means that the electrostatic force of attraction between an electron and a proton in air medium is very greater than the force of attraction between a proton and electron, that is gravitational force between an electron and proton placed at the same distance is very small, and electrostatic force is very large. It is the significance of this ratio. Clear? Now, number 4. Now 1.4. Explain electric charge is quantized. First one is explain electric charge is quantized, and second one is why quantization of charge is ignored in terms of macroscopic or large scale charges. First we explain what is quantization of charge. Charge is quantized. It means that only an integral number of electrons can transfer from one body to another body, and a body cannot have a fractional charge. This is quantization of charge. Charge is quantized. It means that the charge can transfer from one body to another body, or it can receive charge in a definite amount. It is in terms of integers, that is n equal to 1, 2, 3, so on. That is total charge of a body is equal to plus or minus Ne. Plus or minus Ne, where n is an integer and n equal to 1, 2, 3, so on. That means 1 electron, 2 electron, 10, 100, 1000 electrons can possess a body. But this value is not in fraction. This is the quantization of charge. But in case of macroscopic or large scale charges, the property of quantization is ignored, because in large scale charges it is difficult to specify the location of small charges. Hence, the quantization property is ignored and considered that the charge is continuously distributed. Continuously distributed. Clear? Now 1.5. When glass rod is rubbed with silk cloth, charges are transferred from glass rod to silk cloth, and this can be observed in many pair of objects. Show that whether this is in consistence with the law of conservation of charges. When glass rod is rubbed with silk cloth, glass rod transfers electrons or charges to the silk cloth. Therefore, glass rod becomes positively charged and silk cloth becomes negatively charged. But the number of charges transferred is equal to number of charges gained. Therefore, the magnitude of positive charge on glass rod is equal to magnitude of negative charge on silk cloth. Here, during rubbing, charge can neither be created nor be destroyed. Only charges are transferred from one body to another body. And this is in consistence with the law of conservation of charge. Law of conservation of charge. Next, 1.6. In this problem, a square ABCD is a square and 4 charges, 2 microcoulomb minus 5 microcoulomb plus 2 microcoulomb and minus 5 microcoulomb are located at A, B, C, D. Located at the corners A, B, C, D. Then, what is the electrostatic force due to these charges at the center of the square? Now draw diagonals AC and BD. They intersect at point O. It is the midpoint of the square, and at which 1 microcoulomb charge is placed. Then what is the force on 1 microcoulomb charge placed at the center of a square due to 2 microcoulomb minus 5 microcoulomb plus 2 microcoulomb and minus 5 microcoulomb? Then from the figure, the each side of the square is equal to 10 centimeter. That is AB. From the figure, AB is equal to BC is equal to CD is equal to AD. All sides are equal, that is equal to 10 centimeter. But these forces are acting along the diagonals, and the diagonals AC is equal to BD. For a square, AC equal to BD. Then how to find AC and BD? Consider triangle BCD. It is a right angle triangle. Therefore, according to Pythagoras theorem, square on the diagonal is equal to sum of squares on other sides of a triangle. Therefore, this value will be equal to 10 root 2. 10 root 2. If a square of side if A is the sides of a square, then the diagonal BD and AC is equal to magnitude of the side A into root 2. If the side is 10 centimeter, then its diagonal is 10 into root 2. If side is 50, diagonal is 50 into root 2. If side is A, then diagonal BD equal to AC equal to A root 2. It is not necessary to calculate using Pythagoras theorem. And there is a force on 1 microcoulomb due to 2 microcoulomb. Therefore, these distances are considered. Therefore, if AC equal to BD equal to 10 into root 2, then OA equal to OB equal to OC equal to OD, and that is equal to half of AC or half of BD. Hence, OA is equal to OB is equal to OC is equal to OD is equal to half of this 10 root 2 divided by 2 is equal to 5 root 2. These distances are 5 into root 2 centimeter. But from the figure it is found that the force between 2 microcoulomb or force on 1 microcoulomb due to 2 microcoulomb, it is equal in magnitude to the force on 1 microcoulomb due to charge at C. It is also equal to 2 microcoulomb. That is, diagonal end charges are of same magnitude and like charges. Therefore, the force due to 2 microcoulomb at C, it is directed away from the charge, because at the center 1 microcoulomb charge, it is also positive charge, and it is also positive charge. There is a force of repulsion. Therefore, repulsive force acts in this direction. Similarly, at C, 2 positive charge, that is 2 microcoulomb, and at the center 1 microcoulomb. Therefore, force of repulsion, it is in opposite direction. It is in this direction. Therefore, these forces due to charge at A and charge at B are equal in magnitude and opposite in direction. Hence, they get cancelled. Therefore, no force acts on 1 microcoulomb due to charges at A and C. Similarly, at the point B, minus 5 microcoulomb and point D minus 5 microcoulomb. The magnitude of charges are same. The distances are same. Therefore, magnitude of force on 1 microcoulomb is also same. But here, charge at B, it attracts 1 microcoulomb in this direction. Because these are unlike charge, it is positive, negative, therefore it attracts in this direction. And here also, minus 5 microcoulomb charge at D, it also attracts 1 microcoulomb in this direction. Therefore, here forces are equal in magnitude. Q1, Q2 divided by R square. It is same on both sides. Therefore, these forces are also force due to charge at B and charge at D are equal in magnitude and opposite in direction. Hence, they get cancelled. Therefore, the total charge acting on 1 microcoulomb placed at the center of a square is also equal to 0. It is not necessary to calculate the force between a 2 microcoulomb and 1 microcoulomb separately, because they get cancelled. They are equal in magnitude, opposite in direction, hence they get cancelled. Therefore, there is no force on 1 microcoulomb placed at the center of a square due to all 4 charges. Only write this. There is no force at the center of a square because the diagonal forces are equal and opposite to each other, hence they get cancelled. Hence there is no force on 1 microcoulomb charge placed at its center. Clear? Next to 1.7. Field lines. Field lines are continuous curves. Why there cannot be sudden breaks? Explain. And explain why 2 electric field lines never intersect. First question is 1.7. Electric field lines are continuous curved. Consider 2 charges, positive charge and a negative charge. If a test charge is placed here, test charge is very small charge placed near a source charge. Due to force of repulsion, the test charge moves along a path, curved path, and it reaches here. It is the direction of motion of test charge. The test charge moves slowly along this direction up to here due to repulsive force. Then the negative charge, source charge, it starts attracting positive test charge towards it. Therefore, electric field line is an imaginary line drawn along the path along which a positive test charge can move, and a positive test charge moves continuously from positive charge to negative charge, and test charge cannot jump from one point to another point suddenly. Therefore, there are no sudden breaks in electrostatic field lines. Therefore, they are continuous curves. And the second point is why 2 electric field lines never intersect. And suppose they intersect. Consider 2 field lines. This is first line and it is second line. Number 1, number 2. Right? And field lines are the imaginary lines along which a test charge can move. If there is no second field line, when a test charge is placed here, it moves continuously along this direction. And in the absence of first, a test charge placed here can move continuously along this direction. Clear? And if two field lines intersect, then if tangents drawn at the point of intersection, this is the tangent drawn at the point of intersection of field lines. These tangents give the direction of field lines. And now, if a test charge plus Q naught is placed at the point of intersection, it has to move along two directions simultaneously. At once it should move along two directions. Is it possible? No. A body can move along only one path at a time. It cannot move along two directions simultaneously. Therefore, two electric field lines never intersect. If they intersect, the test charge placed at that point has to move along two directions simultaneously. It is impossible. Therefore, two field lines never intersect. Clear? And last problem, 1.8. Here, two charges, 3 microcoulomb and -3 microcoulomb are placed in air 20 centimeter apart. 20 centimeter apart. Then calculate what is the electric field at the center of these two charges. Let O be the center of separation between two charges. Here given Q1 is equal to 3 microcoulomb, that is equal to 3 into 10 to the power minus 6 coulomb. Q2 is equal to minus 3 microcoulomb, that is equal to minus 3 into 10 to the power minus 6 coulomb. Here negative sign indicates that the charge is negative. But to calculate electric field, only the magnitude of charge is considered. Only the magnitude of charge is considered. And due to positive charge at A, electric field line, it is away from the positive charge. Therefore, direction of electric field is in this direction. This is the electric field EA. EA means electric field due to charge at A. It is away from the positive charge. And electric field due to the charge at B. The charge at B is negative and electric field is towards the negative charge and away from the positive charge. Therefore, electric field due to charge at B or negative charge, it is EB. Both EA and EB, field due to charge at A is away from the positive charge, and field at O due to negative charge is towards the negative charge. Therefore, both fields due to charge at A and charge at B, they are in the same direction. Therefore, total electric field at A is equal to sum of electric fields due to charge at A and charge at B. This is the total or net electric field at O. And also find what is the force on a negative test charge of magnitude 1.5 nanocoulomb placed at O. That means you are to calculate total electric field at O, then calculate force acting on a negative test charge is placed at O. First we calculate electric field due to positive 3 microcoulomb at O and electric field due to minus 3 microcoulomb at O. They are separated by 20 centimeter. That is AB equal to 20 centimeter. Convert it in meter. 20 into 10 raised to minus 2 meter or 20 by 100 meter. And 20 by 100 is equal to 0.2 meter. Therefore, OA is equal to OB because O is the midpoint of AB. Hence, OA equal to OB equal to 0.1 meter. Then, electric field due to the charge at A. It is EA. EA be the electric field at O due to the charge at A is EA is equal to, electric field is given by 1 upon 4 pi epsilon naught into QA, charge at A, QA upon R square. Here R is the distance between the charge and the point at which electric field to be calculated. Or it can also be written as, for it is placed in air medium, therefore 1 upon 4 pi epsilon naught, it is also equal to K, that is Coulomb's constant, and its value is 9 into 10 raised to 9 Newton meter square per Coulomb square. K into QA upon R square. That is electric field at O due to the charge at A. Now substitute the values. We get EA is equal to, K is 9 into 10 to the power 9 into QA, that is QA and QB, charge at A and B. QA equal to 3 into 10 raised to minus 6 upon R square, but here R equal to OA, distance between charge and the point, that is equal to 0.1 square. That is equal to 9 3s are 27 into 27 divided by 0.1 square, and 0.1 square is equal to 0.01, and the 0.01 it is also equal to 10 raised to minus 2, 10 raised to minus 2 into here 10 raised to plus 9 minus 6 plus 3 divided by 10 raised to minus 2. It comes in numerator, therefore it will be 10 raised to plus 2, that is equal to 27 into 10 raised to 5. What is the unit of electric field? Electric field E equal to force per unit charge. The unit of force is Newton, unit of charge is coulomb, that is per coulomb. Hence, the unit of electric intensity at O due to charge at A is Newton per coulomb. It can be written as 27 into 10 raised to 5, or for easy calculation you can write 2.7 into 10 to the power 6 Newton per coulomb. Similarly, electric field at O due to the charge at B. The magnitude of charge is the same. Therefore, electric field due to the charge at B is also equal to electric field due to charge at A. Since magnitudes are same, distances are same, therefore electric fields are same. Although we calculated EB equal to K into QB upon R square, that is equal to 9 into 10 to the power 9. Here QB is minus 3 into 10 raised to minus 6 coulomb. But calculating electric field, we consider only magnitudes. Do not take any sign. Into 3 into 10 raised to minus 6 divided by 0.1 square, and that is also equal to 2.7 into 10 to the power 6 Newton per coulomb. Since these two fields are along the same direction, hence they are added. Hence, net electric field E net is net electric field or total electric field. E net is equal to EA plus EB, and here EA equal to EB, therefore 2 times EA or 2 times EB, hence it can be written as 2.7 into 10 to the power 6 plus 2.7 into 10 to the power 6, that is equal to 10 to the power 6 is common. 2.7 plus 2.7 equal to 5.4 into 10 to the power 6 Newton per coulomb. The direction of net electric field, it is along OB. It is along OB. And electric field at A, electric field at O due to charge at A, it is also along OB. And field at O due to negative charge, it is also along OB. Therefore, direction of individual fields and the net field, it is along OB direction. This is the net electric field at O. Then secondly, what is the force on a negative test charge of magnitude 1.5 nanocoulomb? B. Force. Here we have calculated net electric field, and now we have to calculate force. the relation between force and electric field is, we know that electric field E equal to F upon Q, force per unit charge. Therefore, force equal to Q into E or E into Q. Therefore, force F equal to Q into E, net total electric field into the charge placed at O, and that is equal to, charge placed is 1.5 nanocoulomb, can be written as 1.5 into 10 raised to minus 9 coulomb, and E net equal to 5.4 into 10 to the power 6 Newton per coulomb, that is equal to 8.1 into 10 to the power minus 3 Newton. Coulomb, it is coulomb and it is Newton per coulomb. Coulomb get cancelled, remaining Newton. Therefore, force on a negative charge placed at O is 8.1 into 10 to the power minus 9 minus 3 Newton, and the direction of force is from O to A. The force acts along O to A. Why? Because at A it is positive charge and it attracts negative test charge 1.5 nanocoulomb. It is attracted towards A. Therefore, direction of force is along OA. And the charge at B, it repels the charge at O, because charge at O is also negative, charge at B also negative, hence it repulses in this direction, and the charge at A it attracts. Therefore, direction of force is along OA. Thank you. In next class we shall solve 2 more problems on this topic.